Alright, last video of the chapter. So you've got some basic vocabulary to start off this lesson, all based on polynomial functions, what we've done so far. You should be very familiar with the terms zero, roots, solution, x-intercepts. Those are all basically terms for solutions to a polynomial function. And factoring, you know that that's where the final step before we solve or find all of these zeros, roots, solutions. So all of those basically mean the same thing. So quick little lesson about turning points. We know those as our local mins and our local maxes. Now the number of turns is always one less than the degree. So if we have an x to the fourth graph, it could have 3 turns. Okay, and that's how many distinct real zeros it could have. So if it has x to the fourth, then you can have 4 different zeros made up of 3 different turns. So those are just some little background pieces of information for a polynomial function that we've talked about before. So now let's kind of put this together. So you want to make a rectangular box that is x centimeters high, and then it's 5 centimeters longer, and then it's 10 minus the x centimeters wide. So what is the greatest volume possible? And what will the dimensions be? And we're going to round to the nearest tenth of a centimeter. This seems like a complicated task, but with a graphing calculator, this is a very easy thing to do. So it's telling you that the volume is x times x plus 5 times 10 minus x. And you can just type that straight into y1. You do not even have to multiply it out. You can just type it into y1 exactly how you see it in your graphing calculator. And what your calculator is going to do is it's going to sketch out this little graph for you where you're going to have a little swoop like this, and the only thing you really care about is the maximum. This said, what is the maximum volume? So you use your graphing calculator to find a max of 6.1, comma 264.1, and then it says your maximum volume is 264.1 centimeters cubed. That's our y. Now our x are the dimensions. So we know that x is 6.1. So our dimensions, we just plug it back into the original formula. So the dimensions are 6.1 for x by 11.1 for how long it is by 3.9, and all we had to do is substitute 6.1 into all 3 of these x's, and we're done. So if you have a graphing calculator, it makes that problem really simple to do. So we have one more problem, and this is to tie everything all together. Here's one big nasty equation. It actually is x to the 5th power when you FOIL this out. So what you need to do with this is use all of the skills that you've learned in this chapter so far. I need you to factor this completely. I need you to find all of your zeros. I need you to sketch a graph listing all important information and describe the end behavior of this function. So pause the video. This is going to take you a few minutes, and let's see how far you can go. Give it a try. So let's see if you were able to handle this beast. So the first thing, the only thing they keep factored is the first part of this function, because we can't do x squared plus 9. We do not have the sum of 2 squares. So this is just going to be brought down towards the end. So then what you're going to need to do for this is, it can't be grouped, so you use synthetic division, and you're going to end up with x squared plus 3x minus 1. That cannot be changed, so we're going to leave that alone as well. And x minus 1 would have been the only zero that you would have found in your graphing calculator to do synthetic division. So after you factor that, everything gets set equal to 0, and you solve. And this is why this is the only one you found with your graphing calculator, because x is equal to 1. That's your only easy root to work with. I don't think you're going to be able to find -3/2 plus or minus root 13 over 2 with your graphing calculator, and you're definitely not going to have a calculator find an imaginary number. So this has up to 5 because of x to the 5th, and it does. We have our real, we have our 2 imaginary, and we have 2 more real, but these are a little bit more difficult to work with. These are what we call our irrational roots, and that's why you couldn't find them with your calculator. So we have 1 real, which is rational. We have 2 irrational, 2 imaginary. That makes 5 total solutions. Okay, that's an easy way to check because we have x cubed and x squared. We have no double roots, so we have 5. Then to graph it, you already had a lot of the information. The only thing you had to do was find your y-intercept and your max and min. Remember, you already solved for all the roots. So here is our -3/2 minus root 13 over 2. And this guy over here is our -3/2 plus root 13 over 2. So you want to list the exact answer because we know the exact answer from part B. We also have our 1, 0. 0, 9 is as simple as looking at the table. Our local max is just using your calculator to find the max, and same with the min, and that's it. You have everything. Notice there is no plus or minus 3i because they're imaginary. You're not going to see them on the x-axis. They're imaginary solutions. Finally, part D, if you look, as this graph goes to the left, it's going down. So as x goes to -infinity, the function goes to -infinity. As x approaches infinity, the function approaches infinity. And that's it. We've tied everything together from this unit, being able to factor, list roots, graph, listing important information, and end behavior. Alrighty, you are done for this chapter. This is Longo, and I am out. See you. Bye-bye.